The figure below represents a network of physically linked computers labeled A through G. A line between two computers indicates that the computers can communicate directly with each other. Any information sent between two computers that are not directly connected must go through at least one other computer. For example, information can be sent directly between computers A and B, so from A to B, but information sent between computers A and C must go through other computers. So A is over here and C is here. They're not directly linked, so they have to go through other computers. What is the minimum number of connections that must be broken or removed in the network before computer E can no longer communicate with computer F? So computer F is here and computer E is here. They are directly connected and indirectly connected. You can go through other computers to indirectly communicate between F and E. So we need to find out how many of these connections we can break and find the minimum number of connections that we can break so that they cannot communicate with each other. So the easiest way to look at this is to just isolate F from E. So we know that obviously there is a direct connection between F and E, so we would have to destroy that. But we also see that there are many different indirect ways to get to E. So what we'd have to do is isolate F from the rest of the network. So we can do that by cutting off its access. We know that if F can communicate with G, then that means G can communicate with D and D can communicate with E, allowing F to send information indirectly to E. So what we can do is cut off its communication with G. And then we can also cut off its communication with A because A can also be used to connect to E. So if we do this, we see that F, after cutting off these three connections here, in no way possible can it communicate with E. And if we look at this, we cut it 3 times. So the other answer choices here are wrong, either because one, they don't cut enough wires to completely isolate F from E, or they cut too many wires than are necessary. From this configuration here, we see that obviously we don't need more than 3 we don't need to break more than 3 wires to isolate F from E. So obviously 4 can't be correct. And there's no way possible for us to just cut one wire to prevent F from communicating with E. If we were to cut one wire, we could just cut off the connection directly from F to E, but then there would be other indirect ways to communicate with E. So 1 cannot be correct, and 2 can't be either because now there are 3 separate ways that F can communicate with other nodes. Well, 2 ways F can communicate with other nodes to connect to E, and 1 direct way. So you have to cut off all 3 if you want to stop F from communicating with E. So C is the correct answer.